I would personally like to welcome you all to the first ever ESV high-rise building online presentation. Thank you for taking the time out of your busy schedule to listen in to this program. For your viewing ease, you will note that this program is broken into small sections. It can also be viewed multiple times at your own pace and at a time that suits you individually. One of the other benefits of this online presentation is that previously, where we were limited by the number of attendees being able to attend and participate, we have no such issue now. As such, it is highly recommended that all gas fitters working in high-rise buildings set aside some time to view these series of slides. We will also be holding a live webinar in coming weeks. This will give you an opportunity to comment, ask questions, and discuss items within this online presentation that are of interest. ESV look forward to your participation. The following topics will be discussed in this presentation. Schedule 8 Additional Information Requirements. Pipe support systems in high-rise buildings incorporating the means of compliance requirements from the gas installation standard. Understanding performance-based design relating to pipe support systems. Gas piping in concealed locations will highlight what is considered a concealed location and what are the requirements in order to comply. Consideration of various methods to provide flexibility for copper piping systems in high-rise installations. Proposed changes to AS NZS 5601 Part 1 and Top 5 high-rise non-compliances identified by ESV.
My name is Doug Rennie. I'm a gas inspector with Energy Safe Victoria and I'll be discussing Schedule 8 gas application document requirements. To begin, we need to understand why Schedule 8 documentation is required. The Gas Safety Act 1997 has been gazetted by the Victorian Government. The Act calls up the Gas Safety, Gas Installation Regulations 2018, which contains the Schedule 8, listing requirements for additional information that is required in certain circumstances. These circumstances include installations that exceed 3,800 megajoules per hour, exceed 200 kPa, or exceed 10 stories above the ground. The above slide lists additional information to be supplied when seeking acceptance for certain gas installations as explained in the previous slide. These items will automatically appear in GasTrack when your application triggers the Schedule 8 requirement. Our expectation is that all items listed within the Schedule 8 are adequately addressed when submitting your application. At times a response will be not applicable, which is perfectly fine, but an explanation will be required to support your response. Some Schedule 8 applications clearly don't meet our expectations. It is in your best interest to provide ESV with all the relevant information required for the Schedule 8 application. This information needs to be relevant, detailed and comprehensive, responding to each listed item. If the information is adequate for ESV to process the application without requiring further information, this will prevent subsequent delays in the processing of your application. Details of the gas installation, including drawings of the general arrangement of the consumer piping, should be in the form of a legible schematic. The drawings should include a title block with the installation address, the location of any valves, regulators or other control devices, the method used for pipe support, both vertical and horizontal runs, including provision for flexibility where required. For example, anchors, slide guys, flexible hoses and the like. Gas riser shafts or service cupboard details, including location of any offsets. Ventilation details relating to the gas riser shaft or service cupboard. The piping materials, operating pressure, location of submeters, vent line design and its termination point. Any associated electrical circuit diagrams for devices or interlocks that may be installed, such as gas solenoid valves, pressure proving systems, or air pressure switches used to monitor mechanical ventilation. The design pressure drop must be nominated in your application. This requirement relates to the pipe size and not to the gas tightness testing. Allowable pressure drop is usually calculated considering the supply or metering pressure and the minimum pressure required for an appliance or regulator. 5601.1 Appendix F provides guidance for the pipe sizing and allowable pressure drop. Where 5601 is used for pipe sizing and allowable pressure drop, please nominate the sizing table used. Pipe manufacturers may provide appropriate pipe sizing tables for pipe materials not listed in 5601.1 Appendix F, for example, cross-linked polyethylene BX pipe. If determined by calculations other than from 5601.1, you should nominate who has completed the calculations and their experience. Stating in the application that 5601.1 Appendix E is being used as the gas tightness testing procedure satisfies this section of the Schedule 8, but you must also include the pipe volume, operating pressure, test duration, and the test instrument used, which must be suitable for the pressure and the volume being tested. For example, a dial gauge with a range of 1 to 1000 kVA is not suitable for a 7 kVA test. For large volume installations above 30 litres, as is commonly found in high-rise buildings, you may reference ESV Gas Information Sheet 14 in the development of your purge procedure. For branch lines under 30 litres, you may reference 5601.1 Appendix D. A comprehensive purge procedure must be submitted with the application and must also include the purge volume, the purge medium to be used, such as an inert gas for larger installations, the safe purge outlet location, purge equipment that will be used, such as a purge stack, purge buckets, or a suitable gas detector. Provide details about the commissioning procedure for pressure control devices such as regulators, including overpressure shutoff (OPSO) regulators, pressure proving solenoid valves and gas boosters. In most instances, a copy of the manufacturer's commissioning instructions will satisfy this requirement. This is also important information that will be required for the project manager and commissioning staff on site. Manufacturers' data sheets are required to be submitted with your Schedule 8 documentation for all control devices and appliances that will be installed. Data sheets should include information such as installation instructions, product specifications, and certification details as applicable. Where gas cookers are installed, the installation instructions should include both the cooker and the range hood to ensure appropriate clearances are provided. Provide the proposed settings of all adjustable devices. This will include settings for devices such as regulators, overpressure shutoff, pressure switches, and the like. ESV has developed Information Sheet 60 to assist you with your Schedule 8 application. This can be found on the ESV website under Gas Technical Information Sheets.
My name is Kevin Dwyer and I'm a gas inspector with Energy Safe Victoria. I will be discussing pipe support systems and performance-based designs. This presentation will be in two parts, with Part A discussing the means of compliance requirements in AS NZS 5601 Section 5 for the support of consumer piping, and Part B will outline the option for submitting a Section 2 performance-based design for a piping support system where the support method will not comply with Section 5, and discuss the minimum requirements that Energy Safe Victoria expect for a performance-based design application. This slide provides an example of a non-compliant installation and an obvious lack of understanding for piping support requirements and the separation of electrical and other services. It's a reminder of the obligation all trades have to comply with Australian standards and always aim to provide a high standard of workmanship. The term means of compliance relates to the prescriptive clauses and tables in Section 3 to 6 of the standard and the normative appendices that, if met, compliance to the standard will have been achieved. Clause 5.8 and its sub-clauses detail the means of compliance for the support of consumer piping. Clause 5.8.1 lists the requirements for a consumer piping support system, where it must be able to support and restrain piping in its intended position, be installed with components compatible with the piping system. If support system components are not compatible with the pipe material they are supporting, then they must be electrically isolated from the piping system, for example with insulating spaces. Clause 5.8.2 and Table 5.5 detail the means of compliance requirements for the spacing of support devices in the piping support system. And Clause 5.8.3 and Table 5.6 detail the means of compliance requirements for rod hangers used as part of the piping support system. We will now explore these clauses in further detail. Table 5.5 details the spacing requirements for support devices within a piping support system. You will note that support spacings vary based on the pipe material and diameter. Spacings apply to vertical and horizontal runs. Table 5.6 details the minimum rod hanger diameter for a given pipe size. The practice of installing undersized rod hangers at spacings less than those required by Table 5.5 is not a means of compliance with Clause 5.8. For example, 100mm copper pipe requires a 16mm rod diameter at a maximum 4m spacing. Installing a 12mm rod hanger at 2m spacings for 100mm copper pipe is not a means to comply. The normative note under Table 5.6 permits rod hangers with diameters greater than 10mm to be reduced by one size if two reduced size rods are used at the one support point. This concession only applies for the support of one pipe and does not apply where multiple pipes are installed alongside each other, for example on a trapeze at the one support point. The practice of reducing the diameter of rod hangers greater than 10 millimeters and then increasing the amount of rod hangers, thus reducing the spacing of support devices, is not a means of compliance to comply with Clause 5.8. In Part B of this presentation, we will outline the option for submitting a Section 2 performance-based design for a piping support system where the support method will not comply with Section 5, and discuss the minimum requirements that Energy Safe Victoria expect for a performance-based design application. The current gas installation standard includes Section 2, performance-based design and other essential requirements. This section was not previously part of the 2004 AS5601 gas installation standard. Section 2 was introduced to allow industry to design a gas installation as an alternative to the means of compliance sections 3 to 6. Performance requirements are listed for the following areas: general work and safety requirements, materials, fittings and components, consumer piping, flues, and installing gas appliances. Requirements for each area are detailed in clauses just like in sections 3 to 6. Section 2, Clause 2.1 General lists specific requirements when designing a gas installation to a performance-based design. Designs are required to provide an equivalent level of safety, convenience, and efficiency of operation as those installations carried out to comply with sections 3 to 6. A performance-based design shall be documented and kept for 7 years. Practitioners are advised to consult with their insurance provider and the relevant building surveyor prior to undertaking a performance-based design to ensure they are permitted to carry out an installation to a performance-based design. Energy Safe Victoria also has minimum requirements for submitting a performance-based design, including a clear statement that there is a performance-based design as part of the gas application. You will need to attach a separate document that outlines the design proposal. This should be done for each individual gas application where the performance-based design applies. The performance-based design should be submitted with the gas track application. This will prevent unnecessary delay with the final acceptance of your gas application. The performance-based design should clearly state the Section 2 clauses it is intended to satisfy and identify the related clause or clauses in the means of compliance sections 3 to 6. Design applications will be reviewed on a case-by-case basis, and no guarantee is given that a performance-based approach will be accepted by ESV. Information Sheet 63 has been created to provide guidance to those planning to submit a performance-based design for consumer piping support. I strongly encourage everyone that is considering developing a performance-based design to familiarise themselves with the information within this sheet. Information Sheet 63 outlines ESV's expectations for this type of application. Documentation is required from the applicant, with additional supporting documentation from a competent person. This is to verify that the design meets the required performance outcomes. For this type of application, ESV deem a competent person to be either a suitably qualified engineer if it is a custom designed system with no supporting information from a piping support manufacturer or an authorised representative from the piping support manufacturer. The applicant's information should be provided in the form of a cover letter or report. A number of applications received to date have failed to identify the relevant performance outcome clause from Section 2 and the specific section of the gas installation that the performance-based design is to apply to. For example, the piping in the basement car park or piping in the level 5 commercial kitchen. Supporting documentation from piping support manufacturers must state that they have reviewed the site-specific design and have specified a pipe support system based on their assessment. Prior to submitting your application, please ensure all the required information listed in Information Sheet 63 has been supplied.
My name is Alan Hamilton. I'm a gas inspector with Energy Safe Victoria, and I will be discussing pipework installed in concealed locations within high-rise buildings. This presentation was developed to assist the construction industry in the application of the standard regarding gas installations in high-rise buildings. Over the years, building construction methods have evolved and gas installations are required to adapt to new building designs whilst maintaining compliance with the standard. ESV has developed Information Sheet 10 to assist industry in understanding how to meet the requirements of the gas standard as it applies to high-rise buildings. In order to determine what is required when installing pipework in high-rise buildings, we first need to understand what is considered a concealed location. There are three main areas considered to be concealed in high-rise buildings. These are pipe riser shafts, service cupboards and ceiling spaces. Table 5.2 of AS NZS 5601 describes the requirements for piping in concealed locations. This table gives guidance to the accessibility and ventilation requirements based on the operating pressure and the type of jointing method used as listed in Table 4.1. For example, a fully welded pipe with permanent joints up to and including 7 kPa is not required to be accessible or ventilated. However, if non-permanent joints are installed in the same scenario, then ventilation must be provided. Access must also be provided to components such as valves, hoses and spring clips. You will note from the table that pipework exceeding 7 kPa must be accessible, located in a ventilated area and have permanent joints. In order to determine what a non-permanent joint is, first we need to consider the definition of a permanent joint. This is a joint that is not intended to and cannot readily be disassembled. Examples of this are brazed, welded, crimped and hydraulically or mechanically compressed joints. Therefore, any male or female thread, compression fitting or flange is considered a non-permanent joint. We can see in the photo an example of non-permanent joints including the valve, test point and hose assembly. The use of a quick setting thread compound such as lock seal is not considered to be a permanent joint. A pipe riser shaft is considered a shaft that is vented at the top and bottom and open from floor to floor in a high-rise building. It is sealed from adjacent areas and normally fire rated. Consumer piping and components installed in a pipe riser shaft are deemed to be concealed, even if accessible via an access panel or door. When non-permanent joints are installed, pipe riser shafts require venting to a safe location. The riser shaft will need to be sealed from adjacent wall and ceiling cavities. This is to prevent the possibility of leaking gas migrating into the building structure, taking into consideration that the shaft itself should be ventilated to a safe location external to the building. A service cupboard is considered a void that is accessed via a service door and sealed from level to level. Consumer piping and components installed in a service cupboard or void are deemed to be concealed, even if accessible via an access door. Where non-permanent joints are installed, service cupboards will require venting. The service cupboard or void will need to be sealed from adjacent wall and ceiling cavities to prevent the possibility of leaking gas migrating into the building structure. Consumer piping and components installed in ceiling spaces are deemed to be concealed, even if accessible via an access hatch or panel. When non-permanent joints are installed, ceiling spaces will require venting. Ceiling spaces in high-rise buildings are difficult to ventilate due to the building construction, and therefore non-permanent joints should be avoided. This can be achieved by using permanent joints such as crimped or welded fittings. Ceiling spaces containing non-permanent joints, for example occupancy isolation valves, are to be isolated from the ceiling to prevent the possibility of leaking gas migrating into the building structure. This may be achieved by installing a sealed box surrounding the non-permanent joint with an access hatch incorporating ventilation to the space below. Where you have established the need to provide ventilation for these concealed locations, you then need to calculate the minimum size for these ventilation openings. Ventilation openings shall be provided at each end of the area and must terminate in a safe location. Table 5.3 enables you to calculate the minimum required ventilation opening size based on the cross-sectional area of the void or duct. Most service cupboards or pipe riser shafts will have a cross-sectional area less than 7.5 square metres. Therefore, the minimum free ventilation area for each opening will be 0.05 square metres. 0.05 square metres is equivalent to 50,000 square millimetres. This equates to an area of free ventilation of at least 223 millimetres by 223 millimetres, or 9 inches square in the old scale. This is the minimum free ventilation area required for each vent. Please note that grills will restrict the free ventilation area, and the overall vent size may need to increase accordingly. Where service cupboards are to be vented, the vent locations should be within 5% of the top and bottom of the enclosure. This may require a false ceiling to be installed in order to achieve the 5% requirement. Depicted is an example of how ventilation has been provided for the pipe riser shaft. The openings have been calculated to provide a minimum of 0.05 square metres. By coordinating with your builder, these penetrations could be provided by simply boxing out within the riser shaft at construction stage. This will prevent the need to drill adjacent core holes in order to comply.
Hi, my name is Paul Makarievsky. I am a gas inspector with Energy Safe Victoria, and I will be discussing flexibility in piping systems. In many instances, flexibility of consumer piping is overlooked on horizontal sections. For example, pipework located in basement car parks and on rooftop plant decks. This presentation will help you understand where flexibility for consumer piping is required and how it can be provided. Why do we need to provide flexibility? Copper piping expands and contracts with temperature changes. Therefore, in a copper piping system, the pipeline can buckle or bend when it expands unless compensation is built into the system. Harmful stresses, buckling and bending are prevented by providing expansion joints, loops or offsets, and pipe slide guides. Consumer piping shall be designed to have sufficient flexibility to prevent excessive stress in the piping material and attached equipment caused by thermal expansion and contraction, excessive bending or loading at joints, and undesirable forces or movements at points of connection to equipment or at anchorage or guide points. What does this mean to you as a licensed gas fitter? It means that formal calculations may be required where reasonable doubt exists regarding adequate flexibility of the system. Based on these calculations, the requirements of this clause may be satisfied by use of one or more of the following: bends, loops or offsets formed in the piping, flexible joints or couplings of the type designed to absorb thermal expansion and contraction, or expansion joints. So when is expansion required for piping systems? Based on calculations of the rate of linear expansion for copper when subjected to temperature change, we know that internally located consumer piping having a continuous length greater than 35 meters will require allowance for flexibility and expansion to be provided. Copper piping systems located externally are subjected to greater temperature changes, and therefore provision is required for expansion where a continuous length exceeds 17 meters. There are various methods whereby expansion can be provided to a copper consumer piping system. Some common methods include flexible hose assemblies and expansion offsets or loops installed within the pipework. Where provision for expansion is installed, such as offsets and loops on copper piping systems, pipe slide guides may be required. An expansion loop on its own will not necessarily allow adequate pipe movement if every support point on the piping system is rigid. Pipe slide guides allow for the piping system to move with thermal expansion. Expansion provisions for horizontal consumer piping, such as can be found in car parks and across rooftops, can be designed a number of different ways. A couple of commonly used methods are shown on this slide. Option A on this slide depicts flexibility for pipework in straight lengths exceeding 35 meters internally or 17 meters externally. To provide for the expansion of long horizontal runs of pipework, the pipe will need to be supported by slide guides between fixed points, enabling expansion and contraction of the pipework. Allowance for this expansion is to be provided between the fixed points using either a loop, as depicted, offsets, or other suitable means. The size of loops and offsets will need to be designed to allow for the calculated movement. In option B, the pipe layout is designed with an offset to allow for expansion, and runs are limited to less than 35 meters internally or 17 meters externally. In this instance, the main run can be clipped as normal with consideration to the location of clips on the offset, allowing for any expansion to take place.
Hi, my name is David Crew. I'm a gas inspector with Energy Safe Victoria, and I will be discussing proposed changes to AS/NZS 5601. By way of background, the Standards Australia AG6 Committee is comprised of 35 members representing various organisations within the gas industry. This includes the Gas Technical Regulators, Master Plumbers, Gas Appliance Manufacturers Association, and Gas Energy Australia. The current AS/NZS 5601 project commenced back in July 2016, with a public comment draft expected to be released in early 2021. Everyone is given the opportunity to comment on the draft. Once the public comment draft closes, all comments will be reviewed by the Standards Committee, and a second public comment round may be required based on the extent of changes made. The final publication of the standard will be made once the final draft has been accepted by a committee ballot. Some of the proposed changes to the standard include: Section 2 has been separated into essential safety requirements and performance-based requirements. Brazing to be prohibited within 1 metre of a joint with non-metallic components. New drawings including penetration details for consumer piping in cavities consistent with plumbing installation standard AS/NZS 3500 series. Prohibition of the installation of multi-layer pipe above ground and external to buildings. The provision of an emergency isolation for multi-layer pipe installations will be required. There will also be a new definition for fire safety systems. Further proposed changes include increased clearance requirements between domestic cooking appliances and range hoods to align with international standards. There will be an update to the pipe sizing graphs and tables, additional information on the effect of altitude on gas supply pressures for high-rise building installations, revised requirements for the installation and location of flue terminals under a covered area, in a recess, or on a balcony. For example, this means that flue terminals will now need to terminate beyond a covered area. New requirements for the location of appliances on roofs, walls, and elevated structures. Some further works we have lined up for AG6 to consider include the revision of clauses relating to pipe support in AS/NZS 5601, including rod diameter sizes, revision of flue terminal locations, a new biogas installation standard, commercial catering requirements to be included in AS/NZS 5601 Part 2. This information is relevant to mobile catering installations. How can you comment on AS/NZS 5601, the public comment draft? Well, there are various avenues to comment, including through the Master Plumbers, and members can approach the Master Plumbers directly for comment. You can also directly comment via the Standards Australia portal. Submissions must identify the clause that you are commenting on and a proposed solution.
My name is Kerry McDonald. I am a gas inspector with Energy Safe Victoria, and I will be discussing the top 5 non-compliances relating to high-rise buildings that ESV inspectors encounter. Non-permanent joints in concealed locations are often encountered on site by our inspectors. Common locations that this is cited include ceiling spaces and access hatches. The installation of permanent joints such as crimped or welded joints can be used to achieve compliance in these areas. We also find gas pipework terminating within ceiling spaces for future extension by others. Where this pipework terminates with non-permanent joint, such as a plugged isolation valve in a ceiling space, the location must remain ventilated and accessible. Where it is evident that ceilings are to be installed at a later date, it is advisable to terminate the pipework with a permanent joint, such as a welded or crimped cap, or locate non-permanent joints in an area that will remain ventilated and accessible. Another issue our inspectors come across on site is the incorrect clearances provided from cooktop to overhead range hood or combustible materials. The required clearance between a gas cooking appliance and range hood must be in accordance with both cooking appliance and range hood manufacturers' specifications. As the licensed plumber, you are responsible to ensure the clearance from the gas appliance is compliant. As you are reliant on others for the installation of cabinetry and range hoods, it is advisable that the builder is made aware of these requirements in order to pass on this information to other relevant trades. It is important that the installation instructions for both the gas appliance and range hood are available to the inspector at the time of the inspection. Continuing on from Kevin Dwyer's presentation relating to rod hanger size, we are often presented with installations involving multiple gas consumer pipes supported at a single point. As you can see in the photograph, 2 rods have been reduced in size in compliance with the note to Table 5.6, which states, where 2 rod hangers are to be used at a support point, the minimum diameter indicated by the table may be reduced by 1 standard size for all rods greater than 10 mm. This table only applies for support of a single pipe and not for multiple pipes. For installations where multiple pipes will be supported at a single support point, a performance-based design will be needed to be accepted in order to achieve compliance. Service cupboards and pipe shafts need to be adequately sealed to ensure potential gas escapes are prevented from migrating into other parts of the building. As the licensed plumber, you are responsible to ensure that service cupboard and pipe shafts are adequately sealed. In many cases, you may be reliant on others for sealing of these areas. You may need to put a system in place ensuring that this work is completed satisfactorily prior to ESV inspecting the installation. As the licensed plumber, you are responsible to ensure gas consumer piping maintains adequate clearances from above ground, low and extra low voltage electrical equipment. In many cases, you are reliant on other trades to maintain the required separation. You may need to put a system in place ensuring this work is completed satisfactorily prior to ESV inspecting the installation. ESV provides a technical helpline to assist all gas fitters with any inquiries they may have regarding gas installations. ESV has an expectation that all gas fitters make every effort to establish the relevant requirements relating to the inquiry prior to contacting us. Please ensure you have a current copy of the relevant installation standards with you at the time of the call, as this will assist in helping you interpret the standards. Thank you for taking time out of your busy schedules to hear from ESV.